Alright, this is 5-4 multinomial probability distribution. This is video part 1. I would do a practical one for the second video using the calculator. There's no reason to do these by hand, other than practice plugging it into the heinous equation. Alright, so, first off, the multinomial is exactly like the binomial, except you've expanded it to be more than 2 events. Very specifically, there's multiple events, 3 events, or 4 events, or 5 events. And that's why we have the first type, the second type, the third type, the kth type. Right? Just like when we had the permutation rule number 2, which I prefer calling the multinomial rule for counting, that's what's going on here. When we did the binomial, you only had 2 outcomes, a yes or a no. With multinomial, you have first type, second type, third type, for however many types you have. With binomial, you then had to multiply it by all the different ways you could arrange it. That was the n factorial over k factorial n minus k factorial. But for multinomial, you have to multiply it by the multiple ways you could do it. That's why we have permutation type number 2, multinomial counting. Alright, so this formula should be the same. Now, in order to be a multinomial distribution, we have to meet criteria just like we had to meet for the binomial. So the criteria are pretty much the same as the binomial except for one kind of change. So there has to be a fixed number of trials, that's going to be n. Fixed number of outcomes, that's the k, but we're not really interested in that. Multiple outcomes, so there's x1, x2, x3. Instead of just counting the number of successes, we need all of the counts for the outcomes that you want. Again, we have to have the independence, and you'll notice that we lose this independence on other things we do. Specifically hypergeometric, we didn't quite have that. And lastly, the probabilities have to stay the same. And that's the same deal we had with the binomial, where the probabilities stayed the same. So this probability of the first type is the same no matter what you draw. Now, the way I like to think about multinomial is that you're reaching your hand into the candy dish and grabbing a handful of candy, and you want to see what's the likelihood of getting 3 chocolates, 2 taffies, and 1 sucker. All right, in that case, with the 3 chocolates, 2 taffies, and 1 sucker, there were 6 different things we grabbed. That's the N. There's 3 types, the chocolates, the taffies, and the sucker, and it was 3, 2, and 1 for how many we grabbed. The probability doesn't change because you grabbed everything at once. Everything was as likely to be grabbed on that one grab you made. Alright? So, I'm now going to use an example in the book, and we're going to use the calculator to go through one example specifically.